right, here's two poorly drawn box plots, but at least there's a scale at the bottom to give you an idea about what each part of the box represents. And now that I see it in my computer screen, boy, are they crooked. Oops, well, I don't have a ruler to make straight lines. All right, say I have a class that I'm teaching, and it's split into two sections. Kind of like this semester, I got one class split into 3 sections. And maybe I gave both classes the same exam. Remember, y'all don't have tests. Let's say that I gave both sections of the class the same exam, and I want to see if one class is doing better than the other. There are lots of ways I could do that. One way would be to compare the box plots for the 2 classes. The basic box plot. The basic box plots, where the left-hand side of the box plot corresponds to the minimum. The far right whisker on the box plot corresponds to the maximum. Well, in both classes, the minimum was 40 and the maximum was 100. So if I just looked at those 2 numbers, I'd say, ooh, those 2 classes did exactly the same. No, they did not. You might say, well, I want to look at the median. Okay. With the way that I've drawn it, I've tried. The median for the 2 classes is the same. It's 75. That's a solid C. Now, of course, box plots don't have your mean anywhere on here. But I do see my first quartile and my third quartile in the box plots. For section A, my first quartile is 70 and my second quartile is 90. So half of the students in section A scored somewhere between 70 and 90 inclusive. Half the students in section A scored between 70 and 90 inclusive. 1/4 of the students in section A scored less than 70. 1/4 of the students in section A scored more than 90. Half scored between 70 and 90. And the median, which was the halfway point, the midpoint of the data set, 75. Let's talk about section B. Same min, same max as the other class, so if I just looked at those, don't see any difference. If I just looked at the median, hey, their median was 75. Don't see any difference. But when I look at their box plots, boy, do I see a difference. The 25th percentile, or the first quartile for section B, is a 60. And the third quartile is 78. Half of section B scored between 60 and 78. 1/4 of the students in section B score between 40 and 60. And 1/4 in section B scored between 78 and 100. Now I know somebody actually got 100 because I got the little box plotty thing over there on 100. And I know somebody in each class scored a 40 because I've got the whisker on my box plot for each one of those. And this is a basic box plot without dealing with outliers or anything. Which class do I need to spend more time with? Which section seems to be struggling the most? Can you tell by looking at the box plot? You certainly couldn't tell if I said, hey, highest score in both classes was 100. Lowest score in both classes was 40. You're like, those classes sound the same. One measure of central tendency we might look at is median. Well, it was the same in both classes, 75. And then you may want to see the mean, and you may want to see the mode. Well, then you'd have to ask me for my made-up data. But notice that there's different numbers of students in each class too, and I'm still able to look at these box plots and compare them. Section A's got 40 students, Section B has got 45 students. One of those sections needs my attention. One of those sections needs more help from me, more assistance from their teacher. And that section is Section B. Why do they need more attention from me, more intervention, more help? You're not doing as well as Section A. Could be lots of reasons. I don't know what the reasons are. But I can compare two distinct groups on the same measurement, which in this case was a test score. Same test for both classes. I can compare those two classes by looking at their basic box plots and seeing if they're dramatically different. Here's something else I can tell from a box plot. I can tell which one's skewed left and which one's skewed right, because neither one of them is symmetric. If I had symmetry, the whiskers would be the same length on both sides, and the median would cut down the middle of the box. That's how you can tell symmetry from a box plot. The median cuts down the middle of the box, and the whiskers on either side are the same length. Section A is skewed left. That means that I know the mean is less than 75, because 75 is the median. Now, how did I know that this was skewed left? Because I have a long left whisker. There might be some unusual scores over there on the left side of the box for Section A that pulled the mean down below 75. Do I know what the mean is? No, but I know the mean is less than 75 because I know my data set is skewed left because I have a long tail in my box plot on the left. Section B is skewed right. Look where the long whisker is. It's on the right. So if I were to just look at means, I would have a really misguided idea about my two classes. Here's why. Since Section B is skewed right, there's an unusual score or two over there on the right. An unusually high score in comparison to most of the rest of the class, because half the class scored between 70 and 60. The halfway point, the midpoint of all the data values is 75. So 50% of my students made 75 or higher. But I also know that the mean is going to be pulled, affected by that higher score that's hanging out over there, making that right-hand whisker too big. So even though I don't know the means, if I went to you and I said, well, Section A and B, they had the same high scores, they had the same low scores, they had the same medians, but Section B had a higher mean than Section A. Now, I know a lot of you want to call the mean the average, so I'll do that against my will. I could say Section B had a higher average on the exam. You'd walk away thinking Section B was the class that didn't need my help. they do have the higher mean. Box plot doesn't tell me. But the box plot tells me that the mean is bigger than the median because my box plot is skewed right. And so if in comparing the two classes, I just looked at mean, median, high, low, well, the high, the low, the median were all the same. And then if I look at the mean, just that number, I'd say section B is the best class. They have the higher mean. They have the higher average. Statistics or numbers, sets of numbers, graphs, or tables that describe a data set. Having just one or two or three of those things can give you a bad picture in your head of what's going on. In this example, one more time, section A and section B had someone make a 40 on this exam. Section A and section B had someone make 100 on this exam. The median for both classes was 75. The mean for section A was lower than the mean for section B. Why? Because section A is skewed left, so mean is pulled left. Section B is skewed right, so the mean is pulled right. So if I just told you high, low, median, and mean, you'd think section B was the better class. If I just gave you the interquartile range, which for section A is 20 and for section B is 18, you'd say, that doesn't sound that much different. The interquartile range doesn't show you what the numbers were. Skewness, though, tells me a story. The box plot helps me visualize that story. It's section B that needs my help. I hope this made sense. We're going to find out soon.